Okay, so the routers can either be configured manually, giving static routes that are predefined, and being manually entered, it means that something changes in your topology, you've got to do it again. So it requires admin intervention. Dynamic routes are learned using routing protocols, of which there are several I mentioned last week, and they're going to be recapped again today. I'll show you kind of some of the stuff on here. It's a bit hard to read for you folks, but just so you know what's going on. This is the static and the dynamic routing protocols. The static route, this one here, this router R1, okay, knows that the only way out of this place is via R2. There's no other connections to it. Okay, so all it needs to know is just a static route to get to R2. That's all. Yeah? Router 2, okay, similarly, just needs to know about R1 to get to these networks. Itself can get to the internet. So if this router 1 needs to get to another address that it doesn't know about, it can't really go this way to find that out. It can only go this way to get to any other addresses also. Internet, etc., whatever else is out there. Okay. Dynamic routing, this one here. So you've got a protocol called EIGRP, is one you're going to be doing. This one here just simply broadcasts to its neighbors saying, you know, hi neighbors, I can reach this network and that network. And it's routinely broadcasting that out. Okay, it's sending out a message every so often. That's how it does it. R2 here is also going to broadcast out in all directions, saying I can reach the following networks, right? But it's also broadcasting the fact that it also can reach the internet itself, and it is the default gateway to the internet. Okay, so you've got your two different approaches there.
And, sorry, yeah. Does it broadcast as well? The two, because it doesn't know the.
Not broadcast. It's not broadcasted that way because what happens is all done manually.
Okay. Yeah.
So R1 needs to just know the path to R2 is this, and that's also the default gateway to the internet too. If that changed suddenly, then I've got to manually go and reconfigure R1.
Sorry. So if the static routes are not automatically updated,
manually updated. So
is it hard for scalable network?
Is it hard for what? Sorry, scalable network. That's a big issue. Yeah. So if the network is growing and scaling up a lot, and people are coming in and out with devices all the time, not so suitable.
Then in that case, you do dynamic.
Yes, only if the administrator has the knowledge of it, yeah, and is available to set it up and configure it. It's a skill requirement, right? Practical requirement. Yes. So as you just said here, here's some of the reasons why you choose one over the other. This is like business decision making here. Okay, for static, you know, as it gets a bigger network, it gets more complicated. You're manually changing a lot of things all the time. Yeah, you need the admin intervention. It's great for simple topologies. For security, it's more secure because they're known addresses and there's nothing, you know, unpredictable on it. No, it's faster, and it's got a predictable route to destination. Whereas here, dynamic, you know, this is, as networks scale up, no problem. It can handle that, so it can suitable for both simple and complex. If something changes, admin not required, it will do it automatically. Less secure because of the unpredictability of the change. It does use a router, CPU, memory, and link bandwidth also. Bandwidth to all devices are going to be affected by router broadcasts. And predictably depends on what the topology is, the route.
So the route is same always. Is it advantage or disadvantage? It can be disadvantage as well for favor.
Well, these two?
Yeah, the route destination is always the same.
You're saying that's an insecurity? It's both, as always. You know, if I'm jumping onto a network and I want to create a route, if I create a new switch and I want to talk to a router on I know another building appears or another room appears, then I know my kind of configuration already. You know, and it's low management to set up the IP address and whatever it is. It's fine. You know, if I'm one person managing it and one administrator, it's as secure as I want it to be. Who I share my password with, right? But the insecurity is that because I have a known static route, that if everyone knows my route and wants to use that router, then they've also got access to that also. It doesn't go both ways. But that's why you would choose appropriately. So complex network, always changing, developing, not much admin resource available to sort things out manually. you know, good, powerful router, this is a way to go, dynamic. Okay, so again, so just redefining that. So when do they use static routes? So for smaller networks that are stable, they also route to something called a stub network. Here's a picture of a stub network here. A stub is simply just, you know, it's accessed by a single route and has only one neighbor. So one way in and one little network here and just one neighbor on that. It's a small, simple network here like this. It's a stub network, very good for static routes also. Also used to represent a path to any network not found in the routing table. Okay, so if there's something not on the routing table, then you also can use it for that too. Right. Applications are confirmed here. It just says the backup route in case a primary route link fails, a specific network. I mentioned the stub already. And you know what routers do is they advertise themselves. I mentioned the word broadcast, advertise themselves all the time, and they can be quite data laden. So because of that, this approach of a static route helps you to reduce the size of a routing advertisement, yeah, and the periodicity of that. Okay. So here's an example of a standard static route being configured. The stub network is 172.168.3.0. Here it is, your stub network is your stub router. So no need to use a dynamic routing protocol to reach this. A static route is sufficient. It's hanging off the network on its own. That's appropriate. Now, something called a default static route comes up as well. So static route is like the way to get somewhere. The default static route is what happens if there's an address which is not part of, you know, another address appears, which doesn't match an existing address. It's like, what's the fallback route to take? The default static route matches all packets and used when the packet does not match a specific route in the routing table. Yeah. And it can be dynamically learned or statically configured. It uses the quad 0, the 40 dots /0 as the destination IP address. That's how you label it. Yeah. If you label something with that in the configuration, that means I'm making you my default static route for any address which is not a known address. So it's like a gateway of last resort. Definition used for it. Example is when we're trying to connect to an ISP network. Yeah. So when the edge router, by the way, is the kind of on the edge of the boundary of the organization to the outside world. That's the edge router. That's commonly when we use a default static route to get to an ISP in an organization. And it also has only one router to which it's connected. So there you go, there's your connection there. Now, if you've got several static routes, like more than one, like, you know, lots of different ones for different devices and different stub networks, etc., you can summarize them. Yeah. So if I show you a little summary here, an example, you can create a network summary. So here is an example here. These four networks, 20.0, 22.0, 21.0, 23.0, can be summarized using a different kind of route called a summary route. Yeah. That summary route has changed the prefix to /14, okay, to allow you to modify more bits to access more networks. It's a bit confusing, this. What it's just called is it's like what we call an inverse mask approach. And so if you're ever having to summarize a number of routes together, you can modify your prefix and your summary route accordingly to include other networks here. These are 4 networks provided here. Yeah. So giving these bits back allows you to do that. And there's a method for doing this. Some rules for this: they must all use the same exit interface or next hop if you're going to do this. Okay. And they must be contiguous. What's your definition for the word contiguous? I don't know what this means. Sorry? So it's not the exact word for contiguous. Except, yeah, so we've got sharing common border and also in sequence, like together. Sharing a common border that would make sense. Within the, again, the frontier of a wall within an organization is one approach for a contiguous network. Okay. Now then we've got the floating static route. So we've got the default static route we talked about. There's another floating static route. Okay. These are backups, okay, to static routes. These are for redundancy. If a link ever fails, you use a floating static route to connect as a backup. Okay. In this diagram here, here's our normal network. Private WAN link configuration to this router here, like that. If this link ever fails, the backup is this one. Floating static route to the internet. Okay, if it ever doesn't work out, you've got an alternative to get there. What's happening is, this is a direct route to this private WAN, via the private WAN to this particular device. Or if it fails, I can go via the internet to get there. That's what this is showing.
So do we define the floating static route?
Indeed. That's right.
You automatically define it.
You configure it again, then you configure it. Yeah. So you always think about redundancy in the network, backups, things can fail. How do you always have 24/7 access? And how we do this is we can configure it with this thing called the AD, which I mentioned last week, the higher admin distance. I give it a more greater admin distance, trustworthiness, than the primary route. Yeah, let's configure with a higher admin distance than the primary route. An example here, the EIGRP routing protocol has 90 as its AD value, trustworthiness. So a higher value, an AD of 91 or higher would give a backup route if EIGRP route goes down. All right. Who missed AD last week? Is it you, Hermione? Yeah, and maybe Will and Kamara might miss a bit of it. So admin distance is simply in routers and routing protocols, we create a hierarchy of what routes to take based on what's most trustworthy. Some things are predefined, like some protocols have a predefined AD, or we can ourselves also define the AD for them. You know, we can change that and alter it. Yeah, that's the idea of what admin distance is. On to configuration now. So how do we configure the static and default routes actually on the router? What's the technical process? So we have a command for making an IP route, and this is what the command looks like. Okay, it has various elements. The word IP route is used for IP version 4. The network address, which is the destination address of the remote network to be added to the routing table. This is the network address. And you've got your subnet mask of the remote network to be added. Okay, here's where you put your summary address if you want to summarize routes as well. The IP address is the next hop router's IP address. The exit interface is the outgoing interface to forward packets to that destination network. So this router, what interface is it going to take the route out from? Okay. You also can configure the admin distance optionally here and configure that if you're using a floating route. There's some examples given here, okay, with entries for directly connected. It's too small to really discuss, but there's some examples of different options for routers there. Another example there, there's an entry, no entry for the R3 LAN network. So we've got some kind of, if I look at these diagrams in more detail, let's look at these. Here's the R3 table. Here's R3's routing table. R3 is here. It's directly connected to 1.024. It's a little C there, right? And that C means it is connected directly, okay, via the serial interface 1 in this direction, okay? Also, 2 is also connected, which is 192.168.2 dot. It's the second one. Here, this direction, by gigabit Ethernet. That says 2 connected routes there. The next slide, it says, R1 has no entry for the R3 LAN network. I'm going to refer back to that one again. So R1 here. No entry for the R3 LAN network. So 192.168, all this stuff here. There's no mention of it. Yeah. So you see 172.622 and 33. These are these ones and these ones. This is not mentioned. No way to get to R3 from via this, apart from via R2. Oh, it's not right here. It's zoomed out too much. Hang on. So the next hop can be identified when you're configuring it, okay, by the next hop IP address, the exit interface, the next hop IP address, and that exit interface there. So configuring the next hop static route. This is example in the next hop IP address is identified. Let's look at what's going on here. Here's some configurations taking place. So you can see the network addresses being supplied and the IP routes. 16.1 is going that one. This is R1 we're configuring. So it's this route here, okay? And it's saying that the actual next hop is 16.2.2, yeah? And 16.2.2 is where on this diagram? Yeah, right there. Good, okay. Good, and then IP route 192.168.1.0, that's the other network we want to try and get to, which is now this one. We're now configuring this network, okay, as it was missing before. So that's been configured here, and again, where's the next hop interface for that one? Again, R2, right? So you see it's just pointing to the same default position. Finally, IP route 192.168.2.0, this is 1.0 there, there's 2.0 now. Okay, again, this is a route being configured to get to there. Okay, it's not mentioning the interfaces here, no, interestingly. This explains, this goes now through line by line how it's doing this, referring to the routing tables. And bear in mind, if it's not working, one of the reasons might be is because the exit interface is down or administratively down. Okay, so if there's something wrong with it, you need to look for the status of those interfaces, that they've been logged out of and exited properly. You've done the no shut command, you know, as needed in doing configurations on an interface. So it's explaining how the packets are moving through. Now, directly connected static route. So what this is saying is the admin distance of static route is 1, and this configuration going on here, which is just showing how it's been done. Whoa, hey, down here. So we're trying to get the R1 route set up, and it's routing, wants to get to 1.0, which is over here, this top bit, via the subnet mask outside from S00. Okay. It's also adding on the route for 1.0 again and 2.0, and each time the interface is also being included, which you must do for directly connected static routes. Verifying it, if you want to verify something, the way you do it is the show IP route command, and you can add the pipe symbol to look for particular words. Yeah. Okay, this is trying to cut right through to putting out the bits you want. So if you want to ever look for a particular word, you can add this pipe symbol and the words there. Anything beginning with the word gateway is what's going to be shown here on the results. This is showing you now the IP route configured. 1 and 2.0 and 0.0 as well. Okay, oops, let's come out of this. Okay, directly connected routes use the Cisco forwarding, express forwarding method. This gives only on iOS 12 or later, they provide a forwarding information base, which is a copy of the routing table, and an adjacency table. Okay, that includes layer 2. It just has this like database really where it does lookups from, and that's how it's able to do things quite efficiently. Fully specified routes. Let's just check whether the lab is coming up here. So many different routes there. Okay, Fully specified static route. When exit interface is an Ethernet network, fully specified static routes are used. Just elaborating on this. So here's it's fully specified. This is trying to get to the exit of an, when exit is an Ethernet network, which is what this is indicating. Okay, you do a fully specified route. What's different here is the command at the end, G01, is followed by the exact address of that device interface point.
Why there is a separate cable used in Ethernet?
Crossover cable.
Huh?
Why is there a crossover cable here? Okay, so these two routers in the previous example have a red line serial connection, right? Serial WAN link. Red WAN link. Okay, serial connection. And here, I expect in this example, we're configuring R1 to take you out, yeah, not return back. There's not like a route here and route here is not the same. Whereas this crossover cable would imply, you need to be able to go backwards and it's full duplexing here. You need both full duplexing and things going both ways. I imagine R2 will be configured in some way to get to other devices too, I suppose. That's what a crossover cable does, allows full duplexing. Okay, right, so this is a full configuration of a specified static route. And again, you can look that up with this command here.
One question.
Yeah.
Say, for example, I know we have to configure everything in static routing, but say, for example, PC1 is broke, it's not working, and I have my laptop and we're connected to the network. Will it work for a short period of time until we get the IT guys to statically configure my IP address and MAC address of the thing? Will it configure automatically, like a dynamic router? Will it have that functionality?
It depends on how your IP addressing is being assigned. First of all, how's your IP addressing assigned? So if the switch and that configuration is giving you, if it's set up as DHCP, which is the dynamic IP allocation, then your laptop's fine. You just plug in, and it will automatically get. It'll already set up an IP address. The default gateway will get put in, and the mask will go in itself. But if you haven't got DHCP and it's all manual, then you've got to find yourself what the IP address is that's going to work, know what the default gateway is, and know what the subnet mask is, and put that in manually, which you'll do with a network manager, right? Depending on the network. The switch really is handling it, Anything can go into the switch, but what it can do, it all depends on what's allowed really, what the controls are on that network. What's realistically more possible is it's DHCP, like in the college here with DHCP. So I plug a laptop into the network, like if it's the college allows it, the college still sets up something on my machine to make me do that. I still need to be given some kind of a right to do that. Yeah. Okay. These are the verification commands. So you're verifying. These are the sort of ones you'd use. The main ones. Show IP route static. You can do that. Show IP route for a particular IP address. It's tiny though. Yeah, the IP address is being asked for there, and it will give you the kind of like routing descriptor there. And also that's verify. It's how you verify. You might learn these commands, write these commands down, right? How do you do these different checks? How would you verify the routing table of a router? That's how you would do that. That's what you get back. How would you do it for a, oops, oh my gosh. How do you verify a specific entry in the routing table? One line. How do you verify the static route configuration? And there's a show running config. Again, the pipes being used, just examining only the IP route section. The word section is used here. You can jump to a specific section and get only that bit out if you want to look at it. Saves you scrolling through lines and lines of stuff. Okay, zoom out again. Okay, default static routes. They're commonly used. This is what I said. This is what's used when you want to, you want to get somewhere. Okay, there's various routes already defined. But what happens if you've got another address that's chucked in that needs to be resolved, but it's like one of the other addresses? And this is where we use something called the quad 0. Okay, IP address. It's almost like a backup line, last resort. Like, where do I go and look for something if I get this IP address given to me? Where am I going to find this thing? It's commonly used when connecting an edge router to a service provider network. So this is very commonly used for ISPs. internet service provision, or a stub router. Only one upstream neighbor router is on that, situation. It's also used when no other routes in the table match the destination IP address. Because we can't cover all IPs that get looked up, this is how to handle those ones. Here's how it's done. The command, router config IP route quad 0 matches all network addresses, IP address, which is the next hop router's IP address, and what is the exit interface. Quite a straightforward command. And here is a quad 0 being configured. Quad 0, 172.162.16.2.2. So your actual, what we're looking for is this IP address of next hop router's address. So it's going to this little place here. Right at that point there, yeah? So that's where things get forwarded if we can't match with our routing table. Makes sense? Verifying show IP route static, and you'll get back, it'll show you the gateway of last resort and what that is. And that's indicated by an S star if you're trying to find it, okay? That's how you would find that particular default route and what it is. Right, packet tracer activity now. Right, so just checking kind of what materials coming up next. So your activity now is to do the packet tracer activity on configuring IP version for static and default routes yourselves. The commands you've just learnt. The one you want to do is 2.2.2.4. Okay, if you're configuring IP version for static routes. So you can just download that activity now and get into it.